So, good afternoon, everyone. My name is Prashant Khanna, and I'm from Mechanical Engineering Department, Parul Institute of Technology, Parul University. And on behalf of Mechanical and Automobile Department combined, I welcome Purvang Mantri, who is working as a freelance designer and is an active member of most of the societies in which we are constructing, fabricating, and designing vehicles for different kind of events. So he's having a very vast experience based upon that hands-on experience, and he was a design team lead in our college team also. So I welcome Purvang Mantri. So Purvang, am I audible to you?
Yes, sir, yes, sir. Thank you for such a great introduction. Uh, I shall start with my presentation now.
Yes, 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 yes. You may begin. Purvang.
So, is my screen visible?
Yes, it is visible.
So, hello everyone. My name is Purvang Mantri, and to add up to my introduction, I'm actually been to a place where you guys are sitting right now, because I was a student of Parul Institute of Engineering and Technology diploma studies, where I pursued my diploma in automobile engineering. Then in 2019, I passed out with a bachelor's degree in automobile engineering from Parul Institute of Technology. And for a brief duration of time, I was working as a lecturer in the Department of Automobile Engineering in Parul Institute of Technology, where I taught the students of final years the subject of vehicle dynamics and automotive certification and homologation. And I also taught students of mechanical engineering with the subject of automobile engineering. But certainly I had to move forward in career. So yet here we are. We still have this relationship with Parul University, and I'm still trying to spread the knowledge that I'm gaining with my with the time going by. So let's talk about vehicle aerodynamics today. So in today's session, I'm going to talk about what is aerodynamics and what role it plays in the design of vehicle. Why do we have to consider aerodynamics while designing any vehicle? And what kind of forces act on what kind of aerodynamic forces act on vehicle? In those aerodynamic forces, we will talk about drag force. We will see what is coefficient of drag, and we will also see how to calculate power required to overcome drag, and how drag force affects the power of the engine. So simultaneously, we will be looking into lift force and what role it plays in vehicles, in aerodynamics of vehicles. And lastly, we will end this session with some aids to reduce aerodynamic forces. And in that, we will look brief into Bernoulli's principle, and we will talk about some devices that we already know, that are available in market, and we are quite aware of it. And we will see how those devices work into reducing the effects of aerodynamic forces and improving the stability of the vehicles in terms of aerodynamics. So, what is aerodynamics? Now, aerodynamics is a study of how fluids interact with moving body. Now, this is a aerodynamics is a part of fluid mechanics or fluid dynamics. If someone is from mechanical engineering or automobile engineering background, and they are in third year or final year, then they might have studied the subject of fluid mechanics. And in that, we study about two different types of objects. One is immersed object and other is submerged object. So if we think about our vehicles, then technically it is surrounded by fluid. And this particular situation, an object being surrounded by fluid, it is actually known as submerged object. So technically our vehicle is a submerged object, and the fluid surrounding it is our air. So as soon as the way as the vehicle moves, it comes in motion. There are certain forces exerted by the air on the vehicle, and that forces have a repulsive effect which we don't want, which we want to reduce, so that we can have improve so that the performance of the vehicle can be improved. So this aerodynamics is the study of all the forces and the resulting motion of objects through air. So, talking about the goal of aerodynamics in vehicle, so firstly, we have to keep in mind that forces like drag force and wind noise are not desirable in vehicles. So that and they directly affect the passengers' comfort and power requirement from the engine. So we try to reduce the drag force and the wind noise. And if you have owned a vehicle from the year 2000s to 2005, then for sure you will have this issue of wind noise when you're sitting inside the passenger compartment, even though your windows are entirely closed and your AC is turned on, and you're driving on highway at a speed of, let's assume, 80 kilometers per hour, but you're still going to have this minute wind noise passing by because of the skin friction drag. And today's vehicle have actually improved a lot in the terms of wind noise. They have the manufacturers have tried way too hard to make the passenger compartment soundproof so that outside sound doesn't doesn't come inside and hinder the comfort of the passengers. And taking this to another level, Jeep has actually provided with this new technology that they with their music infotainment system and music system, they actually send in a high frequency vibrations through the speakers, so that any outside noise or any ambient noise is cancelled out by that particular high frequency note. Secondly, we want to increase the downforce and reduce the lift force. Now, this second point is actually focused for race cars and sports cars. It is not really taken into consideration with our road vehicles, which we drive as which are as passenger vehicles or for commercial vehicles. But this downforce and lift forces plays an important role in the stability of our vehicle. We will see how they affect the stability of a vehicle further ahead. So, what are the forces? What are the aerodynamic forces that are acting on the vehicle? So, firstly, is the drag force. Now, drag force is a force that acts opposite to the motion of the vehicle. Like if the vehicle is moving forward, then the drag force is going to act on it in the reverse direction. And the lift force is actually a perpendicular component of the same drag force, which uh, which which acts in the upward direction, and it is in order to counteract the force of gravity. Now, this lift force is taken highly into consideration when you are designing any aircraft or aeroplane, because you want to have that lift. You want the aircraft to be flying in the air. But in the situation of our vehicles, we don't want our cars to fly, right? Because we know if our cars start flying, then and we don't control the way it flies, then it is going to end up in a disaster. So we don't want lift force in our car. So instead we want negative lift, which is downforce. And the main purpose of drag force is that we want to reduce the drag force because it affects the power output of a vehicle. We will Let's now see how drag force is calculated. So this is a formula to calculate our drag force, where Fd is equal to 1 by 2 rho v square Cd into A. Now here Fd is the drag force, rho is the density of air, v is the velocity of the vehicle, CD is the drag coefficient or coefficient of drag, and A is the frontal area. So with this formula, we can calculate drag force. But certainly, uh, from this formula, we actually calculate coefficient of drag. So coefficient of drag can be calculated with this formula. We just shift the terms to the opposite side of the equal to sign, and we get to calculate the coefficient of drag. So which is calculated as drag force upon 1 by 2 rho v square into A. And the drag force is actually calculated with the help of experimentation. Now, what kind of experimentation, you might ask? So here we perform CFD analysis and wind tunnel testing. So firstly, with CFD analysis, we make a CAD model and import it into softwares like ANSYS Fluence or Altus HyperWorks CFD. And in that, we run few analysis on different velocities, and we see how how the drag force is increasing with the velocity of the vehicle, and in which portion of the vehicle it is affecting the most. And from that data we and to validate from we capture that data, and to validate that data we have to conduct wind tunnel testing. And we actually when I was a student, we actually got a chance to conduct a wind tunnel testing in Parul University itself. So there is a wind tunnel on the opposite on the other campus of your university. So if you ever get a chance to visit it, please make sure to go in the workshop and check out the wind tunnel that is provided by Parul University. I hope it is still there now. And back then, we performed an experiment on an aerofoil, and we gathered the data of the pressure sensors which were mounted on the aerofoil, and we averaged out the pressure values from the pressure sensor, and from that values we calculated a drag force, and from the drag force we calculated the coefficient of drag. So from this experiment, we came to know that there are certain constants, and to reduce the drag force, we have to work on one particular thing. And if we go back to the original equation, then we can see that we force drag force is actually dependent on density, velocity, coefficient of drag, and frontal area. Now here I would like to remove coefficient of drag is not a variable, because we take that as a constant. We actually find it out from experimentation. So, and secondly, we cannot change the density of air, because air density is entirely dependent on the temperature of the air. So as the temperature of the air increases, the density decreases. The molecules of the air tend to move apart from each other. So that's how the density decreases when the temperature increases. Simultaneously, when the temperature drops, when it is cold, the density of the air actually increases. So if you are traveling in hilly regions, let's say Kashmir or Jammu or Srinagar, in those regions the air density is going to be high compared to the air density here in Gujarat. So drag force is going to affect differently in different regions. So we cannot change the air density to reduce drag force. Velocity of the vehicle is one thing which is dependent on driver. We tend to drive a vehicle. We always are willing to drive a vehicle as fast as we can, but in safe conditions. And so we cannot consider this as a variable. During the experimentation, we can consider the top speed of the vehicle for finding the maximum value of the drag force. So certainly it ends up on the frontal area of the vehicle, which can actually help into reducing the drag force. Now to so now if we now why was I speaking of, like, why was I considering to reduce the frontal area to reduce drag force, is because of the power required. Now to calculate how much power will be required to overcome the drag force, the maximum drag force, then P, which is power, is equal to drag force into velocity. So if we put the formula of drag force into this equation, we get the equation P is equal to 1 by 2 rho V square CD into A into V. So if we simplify this equation, we come to know that power is equal to 1 by 2 rho V cube into CD into A. So certainly, as the velocity of the vehicle increases, the required power will increase with the power of 3. So let's assume if we double the velocity of the vehicle, which means 2 times the velocity of the vehicle, the power is going to be the required power to overcome the drag force on that particular velocity is going to be 8 times more. So and when the power required is 8 times more than the previous condition, the fuel consumption is going to be increased, and certainly it is going to directly affect the speed of the vehicle. So if we want to make our vehicle efficient and highly fuel efficient, then we need to reduce the drag force so that the power consumption can be reduced. And to do that, we have to focus on frontal area. Now let's take an example of Tesla and Audi. Now this is a Tesla Model S and Audi A3. Now the frontal area for Tesla Model S, I can be wrong about the models, so you can feel free to correct me. So the frontal area for Tesla for this car is 2.22 meter square, and the frontal area for Audi is 2.04 meter square. Now here we can see that yes, the front grille is quite less in the in the case of Tesla, as we can see in the Audi. It is actually larger than the Tesla. And when we are calculating the frontal area, we actually neglect this part of this front grille. But so with this, from this assumption, we can say that we can assume that the coefficient of drag should be less for Audi and more for Tesla. But after performing actual test results and looking at the and recording the results, we came to know that the coefficient of drag for Tesla is just 0.23, while that of Audi is 0.25. It is the drag coefficient for Audi is more, with a factor of 0.02. So even though the frontal area of Audi is lesser than the Tesla, somehow Tesla's drag coefficient is less in compared to Audi's drag coefficient. Now we assume to neglect the area of the grill over here, but if we think about it, and if we remember the concepts of heat transfer, where we are taught about this devices called heat exchangers and extended surfaces. So this front grill has a purpose to play in our vehicles, not in electric cars but in IC engine cars. Now these grills actually help the air, allow the air to flow through it, so that there is a radiator behind it, which a radiator and intercooler and a condenser for turbocharged engine, and all three devices are heat exchangers. So they have fins on them, and fins actually are one of the concepts of extended surfaces from heat transfer. So they add up into the surface area of the vehicle, and certainly because of the heat exchangers and the extended surfaces, the skin friction drag of the vehicle increases. So even though the frontal area of of any IC engine vehicle is less than any electric vehicle, but the coefficient of drag is going to be lesser in compared to a front grille car or any IC engine vehicle. Also, and one thing I would like to add over here is the design in particular. So if we check out the design of Tesla, then they have taken the inspiration from bubble. Let me just take a pointer and draw a bubble over here. So yeah, so this is a side view of a bubble. So when the air flows over a bubble, it kind of smoothly and evenly spreads out around it. And this is the inspiration from various sports cars and race cars, and also and also in the cars where they are focusing on reducing the drag force. And so the main goal of not providing any front grille in Tesla or any electric car can result into such conditions, and the air can flow around it smoothly. Now, while in the case of any IC engine vehicle, that is not possible. Now, talking about lift force, so lift force is highly desirable in aircraft and airplanes, where you actually want that particular craft to be lifted from the ground and fly in the air. But if we are talking about our vehicles, our road vehicles, then we don't want our cars to fly, because yes, we all have seen those videos of Formula One cars flying around on the tracks, and they have ended up in huge disasters. So that's why we tend to reduce the lift force over here. And to calculate the lift force, this is the formula: FL is equal to 1 by 2 rho V square CL into A. Now this formula is almost similar to the formula for drag force, only two variables are changing over here. One is FL and other is CL, where FL is the lift force and CL is the lift coefficient or coefficient of lift. Now, lift has a negative impact on vehicles. Now, as I said, if we have seen Formula One cars fly, the back this was back 5 years back. Now, the current generation of Formula One cars are highly efficient in terms of downforce. So the lift if the lift on the front wheels increase, which means it is going to the air is going to pick the vehicle from the front end, and the weight on the front wheels is going to reduce. So certainly you might feel the vehicle to become lighter on the front end, and whenever you give the steering input, you won't feel any feedback, or you will feel any feedback, but it will be much lesser than what it should be. So if the front lift increases, it will actually affect the steering controllability. And similarly, if the rear lift increases, where the rear wheels get lighter, where the weight on the where the weight of the vehicle acting on the rear wheels get lighter, and it shift on the front end. So what will happen in that is it will directly affect the stability of the vehicle. In each and every corner, if your rear end is getting lifted and you go in a corner, or a turn, then somehow you're going to end up with an understeer condition, where you give a certain input to the on the steering, but the vehicle will not turn in that particular direction. You will have to increase the input of the steering wheel to correct the direction of the vehicle, and that understeer condition is not desirable when it is related with with lift force. So we try to reduce the lift force, which in turn increases the down force. So what we want, not in our, like, this is not much desirable in our road vehicles, but when you are considering race cars or sports cars, then we want down force more, and we want to reduce the lift force. So let's now see on different types of devices which help into improving the aerodynamic forces or reducing the aerodynamic forces. So firstly, we will talk about Bernoulli's principle. Now, if you have learned about, if you have been have studied the subject of fluid mechanics, then you have definitely came across this principle of Bernoulli, where he states that the with increase in the speed of fluid, static pressure of that fluid will decrease. So where the velocity, so which means that when the velocity of the fluid is high, it will have a low pressure. So let's take an example of let's consider you are trying to wash your car. You have a hose pipe, a tube, the rubber tube, the gardening hose which we all have at our homes, and you have connected one end with the water tap of your home, and the other end is in your hand. Okay, and now as soon as you open the tap, the pressure of the fluid of the water coming out is going to be much less, and you cannot spray the dirt off your vehicle, right, or of the surface of the vehicle. So what you do is you pinch the front end of your hose pipe which is in your hand, and as soon as you do that, the water coming out of it attains some velocity, and it tends to move further away than it should in steady state condition, which is in normal condition. So as soon as you pinch the end of the hose pipe, the water actually tends to go further. What we are doing here is we are reducing the cross sectional area of the pipe, and certainly with that reducing cross sectional area, the pressure is dropping at that particular point, and because of low pressure over there, the water attains high velocity, like not exactly way too high, but in relative to the actual velocity of water, that water will have increased velocity, and it will move further ahead, and it will have a impact on the body surface, so that the dirt and the grime can be removed off the surface of the body. So we might have learned Bernoulli's principle late in our engineering, but we have been applying it in our day-to-day life. So this Bernoulli's principle plays an important role when we are designing any sort of devices for reducing aerodynamic forces. So let's see how this Bernoulli's principle affect and help into designing certain devices. So firstly, when you want to when you want to reduce the drag force of your vehicle, then first and foremost need to have a smooth outer body. Now if you have ever used an electron microscope, which is used to see the surface roughness of any sheet metal or plate metal or any metal, then you would have experienced you would learn that the sheet metal that we are seeing with our naked eye is not actually as smooth as we think it is. So it has minute irregularities and surface defects which actually can affect the skin friction drag of the vehicle. So what we try to do over here to smoothen the surface of the vehicle is, firstly we apply paint for primer and paint coat, and on top of this paint coat we try to apply clear coat. So clear coat being the topmost layer of the being the outermost layer of the vehicle, it actually helps into smoothing out the surface of the vehicle. Simultaneously it prevents the paint from any environmental effects. So what this paint and clear coat helps is it reduces the skin friction drag. Now what is skin friction drag, you might ask? So let's say you are traveling on your motorcycle. Now usually you wear full sleeves, but I would, if you are usually wearing full sleeve shirts or t-shirt while riding a motorcycle, then I would suggest for one instance you just wear half sleeve or short sleeve t-shirt or shirt, and see how the air flows over your hand or your arm. And on speeds like 60 kmph or 50 kmph, you will actually feel the breeze to be affecting your hand. And this is way too prominent when you are riding in summer conditions. So that particular resistance on your hand that you feel while riding the motorcycle, that is one fine example of skin friction drag. Well, as the name says, skin friction drag. So that's why I gave you this example. So we have to, with the help of paint coat and clear coat, we actually try to reduce the skin friction drag. Secondly, the edges of the vehicle, edges on the body panel, the edges between where where two adjacent body panels connect, we have to make sure that they are as small as possible, because these gaps actually tend to create irregularities in the surface of the vehicle. So if any air is flowing over this surface, and if this gap is a little more, then it is going to tend to make that air to flow in turbulent fashion, and turbulence will indeed increase the drag resistance on the vehicle. So we try to keep the flow as laminar as possible, and we stay away from turbulent forces over here. So first and foremost, we try to keep our outer body smooth. Secondly, we will try and make the underbody smooth as well. Now in case of our road vehicles or passenger vehicles which are currently running on our roads, then the underbody looks something like this. And we have quite a lot of irregularities over here. So first and foremost, we have the engine oil sump, then we have the undercarriage, then we have front suspension lower arms, then there are brake lines and fuel lines and exhaust pipes running through the bottom of the vehicle. Then there's fuel tank. We have rear suspension lower arms, and we also have spare wheel in some conditions at the rear end of the vehicle. In some cars it is inside the boot, while in other cars it is actually at the bottom, in the underbody of the vehicle. So these all of these parts actually uh, tend to break the flow of air. So if let's assume the flow is laminar, but because of all of these irregularities, the laminar flow of air is going to end up becoming turbulent, and it is going to affect a lot. If your main purpose is to make a race car or sports car, so what you tend to do in that particular situation is you want a smoother underbody. And with this smoother underbody, it will help into keeping the flow of air to be laminar, and it will prevent it from becoming turbulent. So secondly, we try to make our vehicle's underbody smoother. Now we have always heard of this particular device. It is an air spoiler. Some call it rear wing. Now, what air spoiler does is, this is actually, I would like to say, this is an inverted aerofoil. So an aerofoil, if we consider the cross section of an aerofoil, then it looks something like this. But in case of our vehicles, we use inverted aerofoils, which is in here, which is been shown here. So aerofoils are actually used in aircraft. So where, where you want to have lift force, so you want to have the wings of the aircraft to be in this shape. while in case of our vehicles, we have inverted aerofoils, which we call as rear wing or air spoiler. So what it does is it actually plays with the velocity of the vehicle. Oh, sorry, velocity of the air moving over it. So air has a tendency to change its velocity based on the length of the surface area it is flowing on. So if we see over here the surface, and let's cut this wing into half. This is the top. This is the top section, and this is the bottom section. So on the top section, the wing has lesser surface area, like the length of the surface area is lesser compared to the bottom end of bottom surface of the wing. So the air has to travel farther distance on the bottom of the wing than compared to the top section of the wing. So what happens here, when the air has to travel farther distance, it actually tends to travel faster. It travels quickly. It actually adheres with the surface of the that particular surface, and the its velocity increases. So as we learned in the Bernoulli's principle that high velocity air has low pressure, similarly with here, as the velocity of the air is going to be higher on the bottom end of the wing, there's going to be a low pressure region below the wing, and the velocity of the air on the top of the wing is going to be lesser than the bottom of the wing, and therefore there will be a high pressure region on the top of the wing. So what will it do is it will generate a down force, which is negative lift, and it will help to generate negative lift on the rear wheels. So in certain cases, we also want negative lift on front wheels. So that's why I've shown a Formula One car over here. So these front wings actually help into increasing the downforce on the front wheels as well. The concept of its working concept is as similar as the air spoiler, and it also helps into making the flow of the air to be in vortex. We will look how vortex generators help into reducing the drag force. So this is one way of this is how air spoilers work. And next thing we have is front bumper splitters and rear bumper diffusers. You see in this image, these these winglets on the front bumper are they actually act as front wing or front air spoiler. The front wing is significant in case of Formula One car, but if you want to build a race car, like we are converting our road vehicle into a race car, then we will end up mounting such winglets on the bumper. But let's focus on front bumper splitter, which is this one, and rear bumper diffuser, which is this one. So what the front bumper splitter and rear bumper diffusers do is they try to generate venturi effect in the beneath the vehicle. So how does it do it? So firstly, if you have like the in the subject of fluid dynamics and fluid mechanics, we have this one particular device called as venturi flow meter. Now venturi flow meter is a device with which is divided into three segments. One is the converging part. So second is the throat, and the third is the divergent part. So as we took the example of the pipe, hose pipe for cleaning our vehicle, where we pinch the hose pipe. Similarly, here in venturi meter, the in converging area, the cross section area of the pipe reduces till the throat, where and in the throat region it remains constant. The smaller cross section area is constant in the throat region, and in the third part the cross section area increases gradually. So if we study the venturi flow meter, then we can see that the velocity of air actually, or velocity of the fluid passing over inside the venturi meter will increase when it enters the throat, and it will come back to its original velocity gradually when it exits the throat. And because there is high velocity in the throat region, we can see the pressure drop over here, which is showcasing the low pressure region over here in the throat region. So we try to generate this sort of venturi effect beneath the car. So with the front bumper splitter and rear bumper diffusers, which are mounted here and here, in the vehicle. So what these do is, when the air starts flowing from the front and it comes in contact with the front diffuser, it actually converges over here, and this is the region of throat, in accordance in accord with accord with this in compared to this venturi flow meter. So this is the throat region of the venturi effect, as we call it over here. So as the cross sectional area, or the area is get reduced in the front end, it tends to move fast from the from beneath the car. Okay, and as soon as it hits the divergent region, it actually uh, tends to come back to its original velocity. So the velocity in this region is actually high, and this can be achieved because of the front bumper diffusers, splitters, and the diffusers. And with high velocity, it tends to generate low pressure, and because of low pressure, it actually generates a vacuum effect beneath the car. Now, as soon as the term vacuum comes in, the because of that vacuum effect, the weight of the vehicle is attracted towards the ground. It is pushed towards the ground, and it therefore increases the downforce on the vehicle. But there is one issue with this, that the air flowing from above the vehicle is high pressure air compared to what is flowing beneath the car. So this high pressure air tends to move down, because as we know, for any fluid flows from high pressure to low pressure. The high pressure air tends to get flow with the low pressure air. So because of this, it can affect the this vacuum effect in negative way. So to prevent this, what we do is we introduce side skirt. So if we look into this image, focus on this image, then these small lips on the side of the vehicle are actually the side skirt. And what these do is, they prevent the high pressure air flowing from the which is flowing on the top of the car to get mixed with the low pressure air beneath the car. And it helps into generate the vacuum effect beneath the car, and which in turn increases the downforce. So that's how side skirt work. And lastly, as we said, we have vortex generators. Now vortex is something that we have tried to try to make with our water bottles in our school days. We used to twist our water bottles and we used to generate vortex in our water bottles. So this is a vortex which we call to bhavandar in Hindi, or something like that. So what this vortex helps is, it actually helps into, like, this is the only way to introduce turbulence which can be help into improving the aerodynamics of the vehicle. So these spikes which you see on the top of the car are actually vortex generators. So what they do is, they help the air to flow in circular pattern from over here. So why is this necessary? So let's focus on this image on the bottom. So when the air flows over the top, over the roof line, there are certain points where the adhesion between the air and the surface of the vehicle gets disconnected, and which is known as the flow separation point. And from there, what happens, the velocity, the air keeps on moving further, and there comes a region where a low pressure region is generated be, after the flow separation point. So because of this low pressure region, the high pressure air tends to move further behind, and it wants to get mixed up with the low pressure air. And this actually in turns add into the drag of the vehicle from behind it. So what we try to do is, so instead of letting the air to flow smoothly over here, we try and generate vortex, or we try and generate vortex so that it has it still sticks with the surface of the outer surface of the vehicle. And that way we can see in this image the low pressure region is highly reduced compared to what it was shown over here. And at times, if you have seen, because of this flow separation point, when you're going on highways, the dust gets accumulated behind the on the rear end of the vehicle, on the this boot door. So this is because of the same reason the low pressure region is generated behind the on the rear end of the car, and the high pressure air actually twirls back and gets attracted towards the low pressure air, and it simultaneously picks up some dirt from the road surface, and it gets accumulated on the rear end of the vehicle. So vortex generators plays helps the air to stick with the car surface by generating vortex of such kind. So as we saw in this image, in Formula One cars, where I mentioned how the wing, the shape of the front wing is particular than compared to the rear wing. So these shape has a reason so that it can generate some vortex behind the front wheels. Now, wheels also have a tendency to increase the drag in the vehicle. So now wheel being, let's take a good, okay. So wheel being a rotating object, this is the side view. Now the air is flowing in this direction. Okay, so it tends to go in. It should go from top and around the wheel, right? But wheel being rotating in opposite direction of the air, it actually interrupts the motion of the air. So what this front wing in Formula One cars or race cars do is they develop vortexes around here, and they allow the air to pass through wheels so that they are not affected by the rotation of the wheels. And that's the importance of vortex generators. And this was the last device that has been introduced with us for reducing aerodynamic forces and increasing downforce, reducing drag force, and help the velocity help the air to flow over the car smoothly. And I would like you guys to think about this, and this can be a potential project for you guys, that you can actually develop a scale model of a car which is already which is already running in a market on our roads, and conduct a CFD analysis on that particular scale model, and try and implement some of these aerodynamic aids, like the front wing or the rear wing, the front bumper splitter, the rear bumper diffuser, side skirts, vortex generators, and implement these in your design and see how it affects the aerodynamics of the vehicle or the model that you have designed. And I know this might take a few hassle, as designing can be a real tough job, but you can do it with some good guidance. And for CFD analysis, you can use ANSYS Fluence and Hyperworks, Altus Hyperworks CFD. And somehow, like, for you guys, it is a good thing that being a student you can get free softwares officially. ANSYS have the student version available on their website. So has Altair. So you can download those softwares. They are also providing learning documentations, so you can go through them. You can take over their courses and learn about the softwares to learn CFD analysis and see how the air is flowing over your design. And then you can also, if you want to take this project even further, you can then make a scale model, get it 3D printed from nearby 3D printing solutions, and get two scale models, one with the original design and other with your particular design with the aerodynamic aids implemented on it. And if your college approves, then you can use the wind tunnel of your college and see how the air is flowing over it, and take the pressure results from the wind tunnel testing and compare it with your CFD analysis, and see and try to validate those analysis with your in your project. This can be a good learning opportunity for you guys. And if you have any queries, then we can take them now.
It was a very wonderful way you elaborated things, Purvang.
Thank you, sir.
And I just asked a few students about if they are having any kind of query. So I'll
Sure,
just
sir.
let you know in within 2 minutes if
Sure, sir.
anyone is having any query. So Purvang, I one student sent me one question.
Yes, sir.
So just take his query. He asked that what is the difference in aerodynamics of a aeroplane compared to a car?
Okay, so let me just take a clean slate over here now. I'll just add another slide, and let's just so the aerodynamics of a aircraft is actually focused on the, like, I'm not an aeronautical engineer, but while studying the aerodynamics, I was just uh, uh, looking over how aeroplanes fly and what we do to make our vehicles stay down on ground, down to earth. So the wings, the design of the wings is the which we call the aerofoil, is something like this. So what it does is, firstly, when as I explained in the slide of air spoiler, which actually has a shape like this, which is inverted aerofoil. I know aeronautical engineers are going to uh, are going to say something wrong about this, and feel free to uh, find feel free to find my mistake, because I'm not an aeronautical engineer. So here the surface of the aerofoil is uh, longer on the top region of the wing, and it is shorter on the bottom region of the wing. So as I explained in the air spoiler slide, the air flowing from the top end is going to going will have a higher surface area to flow over, while compared to the while compared to the air flowing from the lower region. So what this does is, it generates low pressure on the top and high pressure on the bottom. So this high pressure actually helps into lifting the aerofoil up. Am I clear? So with this, the aeroplane and the aircraft is able to generate a good amount of lift force, which can help into easily get it off the ground and flying in air. While in the condition of, in our vehicle's condition, we don't want to fly, because we cannot control it at this moment. Like, if you if you want your vehicles to fly, if you want your cars to fly, then you need to add certain wings on each end of the on each side of the on each side of your vehicle. So but if you don't want to add that and still want to fly, then it is going to be in disaster, because you cannot control the lift and the lift on our vehicle if you are not adding certain aids. So what we try to do is, we try to reduce the lift in our vehicles, which in turn increases the downforce. So as here, the surface area on the bottom of the wing, which we implement on or which we implement on the rear end of the vehicle, it tends to generate low pressure below it and high pressure above it. So the high pressure helps into keeping the rear end of the wing down, and it helps into generating downforce on the rear end of the wheel. Simultaneously, if you are adding such winglets on the front end of the front bumper, then it also helps, it generates downforce in the similar condition. Then we have the venturi effect, which helps into generating vacuum beneath the car, and with this vacuum effect, it actually tends to pull the entire vehicle down, and it generates enough downforce that even the Formula One car has to overcome the downforce of three times its entire weight. So this is the difference between difference in the aerodynamics of an aircraft and our vehicles. I hope I answered your question.
Very well explained. I guess the answer was clear to the student who asked this question. Now, Purvang, there is one more query and one more question actually, and
Yes, sir.
that question actually is from our go kart team. That
Oh, yes, sir.
the question is actually like this: that yeah. So the question is that does the design of spoiler or the design of vehicle aerodynamically considered as novelty?
So I would like to ask novelty being like your entirely new design, right?
Or just an innovation kind of thing?
Yeah, it can be considered because you cannot copy any spoiler or any sort of aerodynamic age design, because let's take an example, like let's just take your go-kart example. You will The driver of your go-kart is going to have different weight and different height and body dimensions than compared to other drivers of other teams. Exactly. So your firstly, your go-kart has its own design. It is not going to be the same as everyone else. So you cannot implement the same aerodynamic age which everyone is using. So, at the end, you might be using the same bumper, the side bumpers and the front and rear bumpers as they are providing with as you guys might be procuring it from the vendors. But if you are designing it by yourself, and if you want to improve your aerodynamics then you can actually design it, and it will be a novelty for sure, and it will be your particular design. So of course that's a novelty, and I would actually suggest you to design your own bumpers and those side what we call it, I don't remember the exact name for go-karts, the side protector bars.
Yes, yes, yes. So that was all, Purvang. There were only two questions that I received from different students. So I hope the rest of the things are extremely clear to all the students who are actually watching it. And if there is any kind of question, then you can definitely come back to me and you can directly contact Purvang itself. He has already provided his details on the screen right now.
Yeah, you can
So
you guys can check out my YouTube channel where I make videos related with automobile engineering. And if you want to learn more about automobile engineering, then check out my channel. And if you like my content, then feel free to subscribe. Secondly, you can also ask me on LinkedIn and my email ID. So this is my LinkedIn profile and my email ID. If you have any queries after this session, then feel free to ask me here.
So I guess we will be ending this session now. So thank you so much, Purvang, for a wonderful session. And I hope that soon we will receive another good session from you.
Sure, sir. Sure, sir. I would actually like to thank you for giving me this opportunity to spread my knowledge that I've gained since the last 2 years.
Okay, so thank you. Thank you so much, Purvang.
Thank you, sir.